I'm going to cover a couple of things. I'm going to cover a little bit more about the if statement, which things we didn't cover along the way, and then I'm going to introduce you to the 3D graphics we'll be getting into at this point on. So it'll be a lot of stuff, so I'll get to it right away. To begin with, if you had a barn, okay, like so, and it had an outer door and an inner door, and you wanted to go into the barn. In order for you to get into the barn, both doors would have to be open. Okay. So say this is door A, and this is door B right here. There's an if statement that says, if door A is open and door B is open, if A is equal to something and B is equal to something, then do what's over here. See, our if statement at this point goes like this. We say something like, if A equals 5, do the stuff over here. That's what we have so far, okay? This says something different. This one says, if some condition is true of A, like for example, it equals 5, it could be greater than, less than, or any of the combinations. And, this is going to be tough because I don't write ands very well. It looks like a G clef when I write them. That's the ampersand, the and sign, not the at sign, the ampersand sign, okay? And B is equal to 3 or something like that. Then do something over here. And that's it. That says that the A door is open and the B door is open, then you can get in there, you can do it. It does the job, okay? Suppose you have a different situation. Suppose you have a barn that looks like this. Yeah, this is door A, this is door B here. Now you can see, if either of those doors is open, you can get in. They both don't have to be open, but one of them has to be, at least, for you to get in. This is what you use as an or statement. Either A is open or B is open. If they're both open, that's fine, as long as at least one of them is open. That statement looks like this. It's a slightly different notation. I would say that if A is 3, for example, or if B equals 4, something like that, then do this over here. This is an or sign. These are the pipes. They're uppercase. They look like some keyboards. They look like a sort of a semicolon. It's the backward slash, uppercase backward slash. Okay, it's way on the right-hand side of the keyboard. So that you get two things. This is the or statement, which goes to this right here. So if either of those is true, then you'll do it. Like for example, supposing you wanted to ask somebody if they live in Alaska and if they are from Alaska, you want to do a certain thing. In other words, if they live in Alaska and they were born here, do a certain thing. So you'd say, well, if whatever, if they live in Alaska, if they're equal to Alaska living, and they were born here, then do something. Okay, that would be the and sign. You want both conditions to be true. If you're in the motor vehicle department, you may want to know if somebody's of the right age and they have good vision. So if both of those is true, you'll let them through and you give them a license, give them a driver's test. Okay, but sometimes it's an or thing. Okay, you can say if you're let's see, a good example of this. Or, if you're a junior or a senior, you're allowed to do a certain thing. So in other words, if you're a junior, you can do it. If you're a senior, you can do it. So if either one of those is true, so it's a junior or a senior, you can do it. Okay? So that would be a test for that kind of thing. So in other words, the and simply says both things have to be true for you to do what you want. And the or thing says one or the other or both of them have to be true to do the other one. Okay? Does that make sense to you? And that comes up a lot in programs, and I'm going to use one today just to show you how to use it. But that's one thing that you should know. Okay. There's always I put examples of these on the date. What I'd like to talk about today in regard to that is if you have a phrase, like if you have a string and it has something in it, a sentence in it, for example. Whatever it is, it doesn't make any difference what it is. You just have this sentence. What I've done is I said, okay, I got this string, it's got a bunch of stuff in it, okay? Now the question is, supposing you want to see if the word R is in there, A-R-E is in there. Remember how to do that? I can say, well, and this is called A, so I say if, well, first of all, I got to get it out. So I say, first of all, I say variable, I'll call it position, equals A dot index of, remember this? R. Remember this thing here? What this simply says is that if A, which is this thing right here, contains the word R, where is it? What letter is it? Well, it's not at 0, 1, 2, 3, 4, 5, 6. You should get a 6 out of this. That should give you a 6 in here. If it didn't find the word R, it would give you a 0. Negative 1, negative 1. Okay, because 0 is a possibility, that's a location. So they give you a negative 1. And so therefore, if it's positive at all, it means they found the word. That's what we were doing before. We were saying if this right here is greater than 0, do something. Because we would find the word we're looking for. Okay? But there are other reasons to use something like this. For example, supposing you find the word, supposing you say you're looking for the letter A. Supposing you're looking for the letter A in here. You just want to find the letter A. Well, it's going to give you the same answer, isn't it? It's going to say, okay, the position thing is 6. Still the same position, you can find a 6. And supposing once you find that letter, you want to take that and the next two letters after it, and you want to put it someplace. In other words, you know you got A, and you want to put these all three letters someplace else. You want to get them so you pull them out for some reason. Well, this is a stupid example, but basically it's the principles here. You find the letter A, then you say, give me the next two letters in A, and put it someplace so you'll have it somewhere, okay? So what you can do is, once you find this thing, there's a function called the substring. That's the generic name of it, substring. And the substring function, there's actually two versions of it. There's sub str and substring. Why there's two versions? I think it was an accident. I think my guess is that they made one before the other, and they didn't like the one they had, so they made the other. It's kind of a peculiar thing to have two of them. They don't do exactly the same thing. That's true, but it is problematic for one reason. Substring, what it does is, when you say substring, something I say B, variable B, I want to take a piece out of this string right here, and I want to put it in B. So what I have to tell it when I say substring, I have to say, where does it start and where does it end? What piece do I want to take? Okay. Well, it's going to start at wherever it pauses because I say, okay, I want to take this plus the next couple of letters. So basically, whatever this is at, right here, I want, I'm going to put the name down here. 0, 1, 2, 3, 4, 5, 6, 7, 8, up to 8. What I'm going to do is, I want to pull a substring starting in position pause, wherever I hit the A, up to position 8. And okay, I want to take it up to position 8, which is, let's say, pretty silly, but that's what we want to do. So you pull that thing and put it over in here. This is where they made the error when they invented the thing. They made a technical error, I believe, and it's still there. What happens is, you go to position 8, and you're not going to get position 8. You're only going to get up to position 7 for some reason. It takes one less than the number you put down, which is really quite dopey. So the thing is, you say you want to take from this character to this character, and you don't get it. What you get is from this character to this character. You don't get them all because they made a technical error. to get position 8, you'd have to put 9 here.
Is this why you say that it gives you a -1? Is that same reason that
What?
0 is like the first?
This is 0 right here.
Is that the same problem though, that they didn't start counting at 1, they started counting at 0?
No, because if the numbers we're using are the actual numbers based on 0. They are based on 0. In other words, these positions right here are based on 0. So therefore that position should be based on 0. It should be the 9th position. Right?
Really
It is the 9th position. But that's what they were thinking when they made this. I believe that's right. That's what they thought of when they made this, which is kind of ridiculous. When you're working with text, you're thinking of where are the letters. You're not thinking of, like how many are there in the string, and does 0 start at 1 or 0. You're thinking of what number is this letter right here.
So it's always 1.
Yeah, that's why they had to invent this. They realized they blundered, and they made a different one, which does it differently. So the question is, that's how they thought of it. That's correct. But if you're a programmer, see, you sit down and you say, okay, I want to get from position what was it, 6 to position 8. You assume that you go from 6 to 8. You assume that because this one is based on 0. So obviously that one should be based on 0 also. And it just doesn't make any sense, you see. In other words, if the first one, if 9 is what you say was true, this right here should be, instead of 6, it should be 7.
Right.
It would be following the same rule across both of the things, which it doesn't, see. That's why I say they simply made a mistake of some kind. By the way, this comes out of basic language. Basic language has a very similar instruction, and only it works right. that's the difference. But anyway, to make a long story short, this can be used. You can use it for stuff as long as you remember that number right there is always 1 greater than the one you're pulling. This other one here is a much nicer version of the thing. STUB-STR. You start at the same position, like here, and then what you do is you tell it how many characters you want. So if you want 3 characters, you put 3. That's how many characters you want. So what it would do is it would take this one included, this, and this. It would do it. So that instruction, when they finally got that one up and running, that was the one that really worked. And the reason why they called it S is because they'd already consumed that word, the good word, so they made up this other one, which is like an abbreviated version of it. So anyway, aside from going to how the language was written, the basic idea is you have 2 instructions. This one here, which you start at this position, and you go to that position -1. And this one here, you start at this position, you take 3 characters from that position, okay? So those are the 2 substrings. And what will happen is, over here in B, over here in this side over here, you'll get that piece. So in this case right here, they pull R and put it over here. In this case right here, we pull R and put it over here, okay? Does that make sense to you? So in other words, they're giving you the chance to pull letters and put them someplace else. Quite honestly, the only reason why I'm showing you this is I put a program up that demonstrates how to use it, just so you'll see this kind of instruction, because when you're working with strings, you do need all the power you can get. And there's one more string thing that you need besides this right here. You sometimes have to know how long, in actual numbers, how long is the thing. For example, including 0. Supposing you have the word ARE, for example, and it's over here, X equals ARE, like that. The question is, how long is that? How many letters are in it? Not really what position it is, but how many letters are in the thing. What you do here is you say X dot length equals X or Y, whatever. So in other words, what happens here is that dot length, what that does is it takes the length of X and puts it in Y. So you know how long the entire word is. So if I said, for example, if I said, this is A right here, if I said A dot length, how long would it be? It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 letters including the 0. Okay, so it's just how many letters are there is what it's saying. So that has nothing to do with the 0, that one doesn't. And that's it, pretty much. That's the way it works. So you have 3 different things. You have substring, subster, and length. And what I did is, on the substring one, what I did is I put a program up there. This kind of a demo. What you do is you plug things into the substring. Like, for example, first of all, you type out your own original, whatever it is. You type this out, whatever you want to put in. You put that in for the original string. And then, for fun, you try to pull out pieces of it using your numbers in these 2 commands right here. You plug in your own numbers. and it gives you the answer. So it shows you what it pulls out and what it does. So if you forget what it does, try it a couple times and you'll see how it all works. The program's just a demo. I just sort of wrote it to show you how to do it. So that program actually gives you some practice. The length one is pretty simple. Just take any string and put that string name dot length, and you're going to get a number, which is the length of the string. Okay. When you're working with strings, that's a big thing. In programming, originally there were two different groups. There was the Fortran programmers, which were mathematician-type people, and there was the COBOL programmers. They were the business people. The business people used lots of strings. They were talking about lots of words, people's names and addresses and everything. And the Fortran guys were doing calculations, so they had these two different languages going. And when they made the new languages, they tried to bring them both together so the same language could deal with both very easily. And that's why we kind of ended up with the basic and after that the different languages. So there it is. These are the three instructions you have. I'm not going to waste your time going through writing the program on the board, which is a fairly lengthy one. It goes like this. If you say a word like banana, for example, like that. If you say banana, the pig Latin of banana is, because this is a consonant right here, it throws it at the back end. It goes banana, B, and it adds a Y to it. That's added onto the end of it. If this was a verb, like apple, for example, to convert that into Pig Latin, all you do is add the AY, because it starts with a vowel here. So you can see that with these instructions we just did, you could take a word that somebody puts in, and you could look at the first letter to see whether you say, is it an A, is it an E, or an I, or an O, or an U. You can do a bunch of O's like that, right? If it's any of these letters, any of these vowels, then treat it like, just add AY to it. If it's not one of those vowels, then it must be a consonant. Then what you have to do is pull off the first letter, which we just did with the substring, and glue it to the end by adding it to the end, and then add AY to that. So in other words, you could, with the instructions, we just have 3 instructions, plus the if statement, which we already used, you could actually write a program that does simple conversion to Pig Latin. Okay. My parents used to use Pig Latin when I was a kid, so I wouldn't know what was going on. And then when I was 18, they stopped because I caught on, and they started spelling. Okay, old joke. Okay, now I want to get into the real stuff. 3D graphics. It was actually started by a guy in Utah, and they weren't sure how to do it. When we had computers, we weren't sure how to make 3D graphics work. It was a weird idea. The idea of seeing something in 3D that was actually out of a computer was a peculiar idea. How did you get that to happen? Movies had never been able to achieve that in the 50 years they were running at that point. They couldn't achieve it, so how are we going to achieve it? It was kind of weird. So what happened is this guy came up with a very simple idea. He said, in the computer, let's calculate spaces and points. Put points in. For example, if you have a sphere, okay, what you do is you put in a bunch of points. And they all have 3 coordinates. They have the X and the Y and the Z. They have 3 coordinates. So each point has 3 coordinates to tell you what it is. And what he did is he simply made a model inside the computer. That doesn't look like one. He made a model inside a computer that kind of looked like a sphere. And at first, all they did was print out those points. They made a picture on the screen of just those points. And you saw it just like that. It looked like kind of a blobby thing. It was hard to see. So then what they said, well, what we should do is we should fill in between the points. So what they did then is, I'll just make a simple version of it. What they did then is they drew lines between the points, like so. And then they sort of gave a better impression of something that had 3 dimensions to it. You sort of had a better impression of it. Then what they did is they said, let's fill in between the lines. So in other words, instead of having just these lines like this, they would fill in between the lines with color. So then they actually ended up with something that looked like a circle, really. It just looked like a circle, because all it was colored in. All of the triangles were colored in. Okay? So the problem with that is you look at it, yeah, it's three-dimensional, but you don't see it's three-dimensional. You can't see it. So then what they did is they invented the idea of putting light on the thing. They said, what if we had a light up here? What would happen? So what they did is they calculated, now this thing's made out of flat planes, you see. It's like they're triangles. They look like that. They're just flat planes and pointed in different directions. And so what they did was, I'm just going to rough this a little bit here. Like that. Okay. So these are sort of the flat planes here that constructed the rough sphere. What they said is, okay, we put the light there. It has an x and a y and a z. It's in some position. And all these points here are all in some position also. So what they simply did is a mathematical calculation. They said if every one of these triangles, I'm just going to draw one from an angle here, every one of these triangles has a vertical. In other words, if you look at 3 points term as a plane, and the vertical is a line straight up from that point, okay? So what they did is they took the verticals of these things, they drew them, like so, in the computer, not in person. Then what they did is they took this point right here, and they drew a line straight to the middle of the triangle. And if that angle right there is very small, it means that this triangle is pointed at the light. So what they would do is they'd use light colors on that triangle to make it bright. Okay? If down here, for example, if you have a light shine down here, and this angle is huge, it says, that's a big angle, don't color that bright at all, color that dark. So that triangle became almost black. And what happened was, by doing that, by making them a different shade of color as you go around, all of a sudden now the things start to get highlights and smooth shading, okay? And the smaller you make these triangles, the smoother it looks. So then what happened was they ended up with a sphere that, was shadowed on this side right here, and had like even a highlight. It was a bright highlight when the thing was shining on it. So you actually look at it now and you say, oh yeah, that's not a circle, that's a sphere. It was, it was all in our brain, but we saw it as a sphere. Now, the thing is, that's how a normal three-dimensional computer screen looks. But now you got movie 3D, which is a totally different thing. That's how, in other words, you can see this on a regular movie film. It looks the same. It's a sphere, it's shaded, and because of our brains, we see that, oh yeah, that's a 3D object. But if you move your head from left to right, like if you're looking at anything, no matter what it moves to the right, the background will slide with the object. Okay, so that right there gives you another clue that there is this 3D different than the 3D we got right here. Because if you move your head left or right, watching a video on the screen, you don't see a change. The circle's still in the same position. If it's in front of a tree, it's still in front of the tree, no matter where your head goes. Because it isn't really 3D, it's just a flat image, that's all it really is. And the only reason why you think it's 3D is because it's got highlights on it, and it makes it look kind of like 3D. But what it lacks is, the normal screen, what it lacks is what they call binocular vision. Binocular vision, which means both eyes. If you look at an object close up, you're kind of cross-eyed. If you look at an object further away, your eyes get more parallel to the object. Okay, that's how it works. And you can tell the difference. Your brain can tell the difference. You look at something close, you can see it's close because your eyes strain a little bit to bring it in. It's very subtle, but our brains are very smart, and it does a lot of experience. So it looks at that, and it can tell the difference. Well, it turns out that you need binocular vision to determine depth, how far things are away from you. That's how, the only other clues you have are size. If the person looks big, he's close to you. If he looks little, he's further away. In other words, you can guess based on size, but as you know, even that can be false. The other thing is the background. When the background moves, does he move with the background? In other words, if there's a shift there between the background, you can see which one's in front because he covers the guy behind him, okay, as he moves back and forth. So that's a clue also. But this right here creates a sense of that you can look at an object and not even know how far away it is, and your eyes can immediately estimate kind of how close this thing is. You think it can anyway. The trouble with it is, even though we have binocular vision, and even though it works really well, we don't trust it. So basically what we need is not only binocular vision, but we also need to have the background shift, and we need all kinds of other things to happen. So what it comes down to is this. In order to create binocular vision, you know you have glasses on. You know how those glasses work, by the way, in the movies? Have you seen them? It's actually kind of a clever idea. They're shooting two images at the screen at the same time. And one is from a camera that shoots from a left side and a camera that shoots from the right side. So the camera that shoots from the left side, let's say it's a sphere, for example. The camera that shoots from one side shoots the light. I'm going to fake it a little bit because it's actually on an angle, but I don't care about that right now. It would shoot the circle like this. In other words, the camera would see the circle over here like that. And the other eye sees it, and it sends it over here like this. Now you may wonder what these lines are. What these lines are is polarization. When you get a piece of glass and you make it a certain way, it has lines in it that allow light. For example, light goes like this. Light goes up and down, and it goes back and forth. It has waves. But if you make very thin slits in a surface, very thin slits, and send light through it, the ones that go up and down bump into the slits and they disappear. And then all you have left is the ones that go sideways. In other words, that's the only waves you have left. So in other words, the waves are going like that. The ones that went like this, which were the same color, are gone now. They get knocked off. Okay. So what happens in the movies, what happens is the left projector kills the horizontal and just shoves those vertical ones down on the screen. And then the right projector shoves the vertical and doesn't show you the horizontal. So they're both showing two different things. They come together over here. And then your lenses have Polaroids in them. So if the Polaroid's like this, it doesn't see the horizontal one. And if the Polaroid in this eye is like this, it doesn't see like this. It doesn't show you the vertical one. So in other words, each eye is looking at different things. And so it can only see one of these two images, even though they're right on top of each other. You can only see one with each eye. And so the consequence is, you're seeing what the two cameras saw. One camera was over here, one camera was over here, and your eyes are now those two cameras. And that's how they make a 3D effect out of it. They make binocular 3D effect. And we can do that in the computer too, by the way. You can do it on your own computer, but it takes a little bit of work. You get some kind of a little bit of hardware, but not very much. There are old-time movies where they would show you they have a red lens and a blue lens. You've probably seen those. They do the same thing, except obviously it's going to screw the color up. But it does the same thing. The blue image can't be seen by the red lens, and the red image can't be seen by the blue lens. So they put them on top of each other, and you see a three-dimensional object with, spurious color. The good thing about Polaroid is it's black and white, so they don't care what color. It'll do it for both colors. Okay, so that's how they do it. But we're not going to do that. We're going to do 3D in a way that's a little different. The first thing we do is we create perspective, so things that are further away are smaller. That's the first thing we do. Okay, but it's automatic. It takes care of the 3D world. The programming takes care of that. If you tell it it's further away from the person, it shrinks it automatically. It knows how to do it, so it takes care of all that work for you. The second thing it does is all the objects are designed so that if you move an object, you can see them getting in front of each other, so they pass in front of each other. The objects move, so that's another clue this is a 3D world. So in other words, what 3D does in our 3D universe on a flat screen is it simulates those things that can be simulated outside of binocular. It doesn't have that. We could have it, but we don't have it. So in other words, if you create a 3D world, you basically can see this thing in front of you, move around, you can move things in front of each other. You have control over all that stuff, okay? And that's what gives us the 3D effect. It's all in your head. It really is a matter of putting it in your head, because actual 3D is what it is, and you just have to have some way of perceiving that is 3D. Okay, so here's what I want to do. I want to take all that stuff, all the numbers, the planes, the triangles, all that stuff, and just blow it away. We don't care about that. What we're going to do is we're going to come right into the business having all that stuff taken care of us, and only we have some rules that we have to obey in order to get the 3D to operate. So for example, if you wanted to put a plane on the screen that's three-dimensional, that you could turn around and look behind it or swoop it around, you should be able to do that. If you want to put a sphere on there that has a shadow and everything, you should be able to do that, or a cylinder, or any object, no matter what it is. And when you go forward, everything should come back by you. When you go backwards, everything should go this way. When you turn left, everything should be over there. In other words, we want to be able to have it like a game, like all the things in a game. You'll be able to move around and see stuff. So, what we need is a basic program, essential program that takes care of a lot of that stuff for us, but then we have to do the work of actually writing the code for it. It's just like when we're doing HTML. I mean, the screen's right there, and you see the picture, you see the words, you see all that stuff, but behind it is your code that makes that happen. This is the same thing. Behind it is your code that makes that happen. We don't control what HTML does. We're stuck with it. We just do whatever it does. But we can write code to tell the machine what to do, and that's what we're doing here. We're going to write code that will tell the computer to make this stuff in 3D and do it on the screen, and that's what we're essentially going to accomplish. Okay, so to begin with, I just want to make sure I cover everything here. The first thing you should know is that when you create an image in 3 dimensions, we're creating what they call a scene. The scene is the thing. The scene is what people look at. You're looking at the scene, okay? You create this 3D scene, and there they are. They sort of call it a scene, okay? In that scene, each object that's in there, no matter what it is, has to be oriented to the origin of the scene, wherever it is. In the scene, there's a y-axis and an x-axis, and coming towards you is the z-axis. This is the one that comes off the board up towards us, okay? And this is the x over here, and this is the y up here. That's positive, this is positive. Notice it comes towards us. And that's the origin right there. And it's sort of some arbitrary position, okay? Just assume it's in space someplace. So the thing is, supposing we put a cylinder right here, and we want to see that cylinder from out here someplace. So what we have to do is, we're the camera. We are the camera, okay? So what we do is, we say, okay, we're the camera. We want to back the camera, bring the camera up in the Z. We want to make it positive Z to move back away from this thing, to look at that, to see what it looks like. Because otherwise we're going to be right in the middle. Everything is invented right in the middle when it starts. Every single object you create is right in the middle. And you immediately have to say, oh, and I want this out here, and I want that over there, I want this over here. You have to orient them and everything. So basically, you and the camera and everything's in the middle to start with. So the first thing you want to do is you want to move back out, away from the object, to look at it, so you can look at it, okay? So remember that, you're the camera, and the scene here has that origin right there built in. Once you build the scene, that's there, that's located for you. Every object you create, no matter if it's a cylinder, sphere, whatever it is created, its location is a 0, 0, 0. Which means its x position is 0, its y position is 0, and its z position is 0. Oh, whoops, up here, 0. So there's an x 0, y 0 this way, and z 0 that way. So everything's created in 0, 0, 0, x, y, z, like that. Those are the 3 coordinates that tell you where everything is. Any object has, no matter what the object shape is, the middle of the object, it's like the, I don't know if they use the geometrical or, it can't be the gravitational, probably the geometrical center, the average of all the points is right at the center of the thing, no matter what shape it's in. The center of it's at O, when it's invented. It starts right there. So say I want a sphere, it'll be right in the middle. Okay, so whatever you call for is going to be in the middle, including you. The camera itself is in the middle. You're all there. Everything's in the middle. It's like the Big Bang. You're the Big Bang. You pull everything away so you can look at it and see what it is. So that's the first thing. You've got to get used to the idea that that's what's going on the screen. So when you see the screen, and you see, like when you go on a normal program, you see this, and you see a block over here, or some objects go all the screen, you're back here looking at it. Several things have happened. The first thing is the person who created it moved the cylinder over here, moved the box over here, and moved you back so that you can see the things. So everything was moved away from the center so it's all visible to you now, okay? And that's how it kind of works. All right. Get rid of this. I just want to hit these highlights because these points here, once you get these things down, you're kind of rolling along. Every object on the screen, including the camera, can move to the x, the y, of the z, y of the z. You can move in all those directions. You can move them by simply changes their locations. They'll move, and you can rotate them. You can rotate them around the y-axis, around the x-axis, which would be this way, around the z-axis, which would be this way. So you can rotate objects. You can move all the way around. That way, you can get them in any position on the screen you want, any rotation positions or any location position. So there's three different things that you can do. You can move a thing in the X direction, the Y direction, and the Z direction. You can do that. Or you can rotate over the X-axis, over the Y-axis, or over the Z-axis. You can rotate it over those three axes, however you want. So therefore, any object can be in any position, basically. That's how it's done. Okay. By the way, well, I don't want to get too technical, so I'll just leave it at that. Okay, next thing. When you create a program that uses 3D graphics, it looks like this. This is what the basic program looks like. You have HTML, just like we normally do. You have head, just like we normally do. You have JavaScript, just like we normally do.
Script type equals text slash JavaScript.
What?
Script type equals text slash JavaScript.
What'd you say?
Script type equals text slash JavaScript.
No, not that one. We have language equals JavaScript in this case. You could, by the way, I have to tell you, both of those work. It's really weird.
So
Both of those work. This is another condition that happened. There were so many things going on when they were inventing these things. So many people were working on it. It just became like a maze. I stick to one because I don't want you to get confused by all the others. So I just stick to the same ones all the time. That makes it a lot easier. Okay, so you have that. And then what happens is, this is the end of the script down here. Then you have slash head.
Slash HTML.
Then you have body. Just have body normally. And this right here is a new one. Let me get a program to make sure I want to give you the right address, even though you'll be able to see it on your own later. Okay, it's right out in the open. This is it. That's the only thing you really need right there. That contains, normally we put our include files up in here, but for technical reasons, we have to put it down here this time, okay? So put it down here. This is just this inclusion, that's all an include file. That contains all your graphic controls. It contains your mouse controls, just like we did mouse stuff. It contains a keyboard. It contains a bunch of stuff. So in other words, this right here is like a master file that contains everything. It's quite cool. It contains all of our stuff. So you get one include file, and it gives us a lot of power. After a while, you'll see what the possibilities are. And then what you have to do, supposing I want to create a simple plane, I want to create a plane, and every single plane we have has to have a picture on it. That's how we color them. If we want to color something red, we simply have to find a picture someplace, a JPEG or something, and put that red paint, just put that right on the plane. So in other words, we color things by simply putting pictures on it, whatever the picture happens to be. Okay, it makes it very simple. Otherwise, you'd have to get into colors and all that blah blah. We don't care about that. So basically, here's what you do. You say, I want to create a plane, a simple rectangular plane. That's all I want to do. So you put down a script like this, like so. And don't put a JavaScript or anything like that. It's not necessary. And then you say variable. I'm creating this. This is the creation of a plane. I'm going to call it my sign. I just give it this. This is my name right here. My sign. That's my sign is the name I gave it. This is what I'm going to call my rectangle equals. Then what you do is you write the word new and create a space right there. There's a space after the word new. And then you got to use exactly these words. Make plane, all lowercase. Make plane, which simply says, I'm going to make a plane, or a rectangle, and it's going to be called my sign. I'm giving it the name my sign. And I want that plane to be 320 in the x direction, and 240 in the y direction, and I wanted to have, quote, this picture on it, and the picture is called easy in this case, easy.jpg. It's a JPEG, like so, and /script. That right there, I can just say it's over now, /body /HTML. What I've done here is I've actually created the plane. The plane's created. We don't see it yet. You can't see it because we haven't set up a place to see it. What you have to do in order to see anything up in Java, I have to create JavaScript. I have to create a place, a scene where this thing is going to appear. That's what you need, is a scene for it to appear in. Okay. So here's what you do. Here's how the scene goes, and I'm just going to give you the basics just to start off with. I'm not going to give you the whole thing. Function, as you'd expect. And our function is called render. Some people do it differently. I always call it render. Okay, like that. And what render does, render is the function that actually creates the scene for us, so we'll see everything. It'll all be there, it'll come up on the screen. There it is. In other words, normally we write HTML. Whatever you write down here comes up on the screen. Not so. In this case, what we're doing is we're creating a three-dimensional space, and it has to do some work to get it all lined up for us. So therefore, it's all done up in JavaScript, okay? And it uses the information from GraphicsXX to construct everything. What GraphicsXX does is it looks at this thing, for example. It says, oh, they want to make that. This guy's doing that. It's saying, well, they want to make a rectangle that's 320 by 240 and has that picture on it. So it doesn't. It gets it all ready for you. That's what graphics is doing for you. The work is doing for you. But when you actually want to see it, you have to create the render function, which is where it's actually shown. Okay. Now, I'm going to get rid of this stuff because it's online. You guys see it online, but this is all there is at the bottom. That's all you see down at the bottom. There's nothing else. Now what I want to do is I just want to show you the render function that actually renders the object we just created, which is kind of crucial. So, here's how it works. You open up, the first thing you have to do is you have to write this. Now I'm going to tell you why you write it in a second. Request animation. That's a capital A right there. Frame. And there's no render here. These are all lowercase. Like that. See, this is the render function right here. This says request animation frame at render. Here's what that means. When you're doing a 3D graphical world, it assumes you're doing it in time. It assumes that everything's not going to be static. So what it does is, it draws the sphere, and then if you don't make any changes in it, it draws it again, and draws it again, and draws it again. Every time it gets through, it just draws it again and again and again. That's all it does. However, if you move the sphere, when it goes to draw it the next time, it's going to have it in a new position. So that's why it has to keep, in other words, once you turn this render thing on here, it has to keep doing it. It has to keep going over and over and over again. Otherwise, it'll be static. So this guy right here says, get the new frame. As soon as you hit this thing, get the new frame, go back there and do it again. Do it again, do it again. It keeps going back. So it's like a looping thing. It forces it to go back to render every time. It draws the whole screen, goes back again. So what you end up with is a dynamic screen. Something's actually going to be going on. Okay, this is going to look weird to you, but the first object, I called it my sign, right? My sign. That's the name I gave it. It's a plane. I made it into a plane. This has got to be here. If you have a plane, if I define this as a plane, that word has to be here. So there's the name I gave it. Dot, it is a plane. Dot, position. This looks like long stuff, but it's very easy when you actually think about it a little bit. Equals 0, I'm going to say it like that. Okay, here's what happens. Once you create the thing, you have to actually show it to the world. You have to say, here's my plane, here it is. So the first thing you have to do is you have to tell it, where is the X, where's the Y, where's the Z, where is this thing in terms of the scene, where is it? And which way is it rotated? Is it rotated a little bit or a lot or straight or where is it, okay? So you need to give it 3 instructions right off the bat. You have to say, well, it's at X is 0, Y is 0, Z is 0. It's just right in the middle, that's all. And then you say, don't rotate it, X, don't rotate it, Y, don't rotate it, those, don't do anything to it, but show me the X, Y, Z and the rotation X, Y, Z. Show me where it is. And so you have to write this, then you have to write my sign, whoops, my sign. This is a lot of work, but it's essential for this stuff. I have some shortcuts later, but this is plane, position, dot Y equals 0, and my sign. And whatever object you have, this is it right here. This is saying position Z equals 0. There it is. At this point, you know that here's the world. You know that your plane is right here in the middle. It's right here in the middle someplace. It hasn't been rotated, or so far, it hasn't been, nothing's been done to it. So then I say, okay, how is it rotated? I have to tell it that. So I say, okay, my sign, dot plane, dot rotation, dot X. Rotating around the X-axis, 0. We don't want to rotate it around the X-axis. And it's the same for all the others. There's 3 of them, there's 6 of them altogether. Sign, plane, dot rotation, dot Y equals 0. And this one's my sign, dot plane, dot rotation, dot Z equals 0. There it is. That's it right there. These are the rotation ones. So that says this thing is going to be right here in the origin. So right there, when the screen comes up, you don't see the axis. You're just going to see this right here. That's all you're going to see. It's just that object. Now, that object is going to have the picture on it that you put in. Easy.jpg is going to be plastered right on the object. So that's what you see. That's what you see. You see a rectangle with that picture on it. That's all you're going to see. Okay? And at this point, I haven't done anything as far as I have to finish this function right here. I just started render. I haven't finished. There's some more stuff to do. But here's the thing. The one thing you have to remember in 3D graphics is that everything moves. Everything can move around. So you've got to be careful of that. This rectangle right here can be rotated like this. Okay? Or the camera could go around it and look at it over here. That would give you the very same image, because whether it rotates this way or whether you go like that, it's going to give you, the world's going to look the same. Unless there's any other objects in the background, it's going to look the same. So you've got to remember there's 2 different ways of rotating this thing. One is you rotate the object itself, and that's done right here. That's how you rotate the object itself. And now I'm going to get into what happens to the camera. The camera is you, and you can control that too. You can control where the camera is, where it looks, what it does. And so we're going to control the camera, so we're going to say, always keep your eyes on the middle of the scene. Because otherwise, if you rotate the camera, it'll be looking off into space someplace. You say, what am I looking at? Where is it over here? You want to keep the camera looking at what's going on. So we want to do that. And we want the camera to be back away from the origin so it can see stuff. We're going to have to see what's going on. And so in order to do that, I'll show you how that's done. Okay, that's a fairly easy thing to do. Okay, so at this point, all we've done is we've controlled the object. Whatever object you created, that one right there, I've told it just to put it in the middle of the screen. That's all I want it to do. Second case is, what do we do with the camera? What is that doing? What are we doing now while this is going on? That's what comes after this. So in other words, this is all inside the render, and the next thing is inside the render also. It's also part of the render, okay? But remember, these things are easy. These are always the same. These are always the same. That never changes. These right here, you change the names, but whatever object you named it, then you have to tell it which position to be in. We'll move the positions later, but right now they're all in the cell. I'll just leave it there for simplicity. Okay, so there we have it. Next question, what goes on down here? What goes on down here is controlling the camera. And that's really controlling the entire scene because you're looking at everything that's going on. So the first thing you want to do, I'm going to write them down one at a time. The first thing I'm going to do is I'm going to set a background color. When you have the picture, there's going to be a color in the background. In other words, wherever there are not objects, there's a color in the background. We can put something else here. To begin with, you should have a basic color in that background. If you don't put it in, I believe it goes to white. I believe it goes to white. Sometimes it'll be a white background. If you don't do anything, it'll just be white, which is kind of cornball, really. So usually it puts a color in it. I usually make mine black because it's kind of stylish. Right down here, the word you write down is renderer. Remember this now, this is not render, it's renderer, okay? That's a different word, that's not render, it's nothing to do with renderer, is different. You say set, that's so lowercase, clear, uppercase, that's uppercase, color, that's uppercase. And then you set it up like this. I'll tell you how to do it in a second here. 1, 2, 3, 4, 5, 6, comma 1. There it is, right there. Okay. This looks kind of weird, but basically what you're doing here is you're saying, what is my background color? That's always 0. This right here is just the color. Like just it could be all F's, it would be white. All zeros, it's black. Okay. And that right there is opacity, if you see through it or not. Okay? So that's all these numbers are. This is the same as we've been using when they're in a different position. That's the color, whatever color you want goes right in here, and that'll be the background color for you. Okay, so that's the first thing you want to do, so you're setting the world up and saying, what does this scene look like? The next thing is, you want to know what's the camera position in the X and Y direction. Because the camera, I always set the camera so it doesn't go overhead very much, it just goes left and right, okay? And so it doesn't do very much in that direction. When you want to, it's hard to calculate verticals, and I'll explain that in a little while, or next time. But basically, your camera wants to move like this in the X and in the Z direction, sorry, X and the Z direction. You don't go in the Y very much. That leaves you out. When you're walking around, you don't go in the Y direction, you go in the, you go in the X and the Z. And it's sort of like that. I assume that the camera is like a person walking around. So I leave that Y out there temporarily, but we'll get into it later. But essentially, what I want to know is, where's the camera in the X position and the Z position? Those are the two positions that are really necessary. I have to know where it is, okay? So I say, okay, let's put the camera right here. Dot position, just exactly like that up above. Dot X equals 0. I'm going to put it in the 0 position. So in other words, the camera is not going to be anywhere this way or this way. It's going to be right in the 0 position as far as X is concerned. But I am going to go in the Z direction. I want to get it out here so I can see what's going on. This right here is exactly the same instruction as the one we had previously. We had our object. Our object was positioned X equals something, right? We're telling this, the camera is going to be X position something too. Let's put the Z position up. Camera, dot position, dot Z. I'm going to set that at what I said it. I set it at 300. I'm going to tell you right now, these units are just units. You don't know what they are because there's no way to know what they are. Okay, you just think of it as units, as your basic units you work with. In there, you can call it inches, feet, whatever you want to call it. It's whatever you work with. And it will, obviously, if you're doing in inches and you think of it as inches, 300 inches will be one thing. And it'll be consistent with all the rest of your objects that you've made in inches also. If you call it feet, it'll equivalently be the same thing, except everything else is measured in feet, so it gives you the same proportion. So in other words, the units don't make any difference. It's just whatever you want to think of them like. Okay, so next thing is, now what I've done is I put the thing at 300, so the camera's out here. Next thing I want to do is, I want the camera to look at the middle. I want it to always keep focusing on the middle of the origin, because that's where all the action is. And we're the lookers, we're the camera, so we want to get back and look and see what's going on in there all the time. So what you do is you have a special instruction. It's called camera dot pardon me, look at, where the A is capitalized, look at, scene dot position. Okay? And that's it for the camera. The camera's all set up, the camera's now operating. these three guys right here, I told them where it wasn't X, where it wasn't Z, which is where we only, one place, there's X, Y is going to be 0 automatically. They're all start with 0 automatically. I could have left that one off too if I wanted to. The reason why I put it in is because in most of our programs we calculate, we move the camera to different places in the X direction. So I wanted to be sure it had a place where I could change it to something else before I move it around. Okay, so basically, this right here is all you need to get the camera to back off, keep looking at the scene. At this point, the thing would run except for the fact that we haven't actually rendered anything. There's a couple of magic instructions to say, now draw the picture. We've set it all up, everything's set up, but now we have to say, draw this picture. And here's how it starts. Let me get rid of this. Remember, this is just down here. There's only 2 more instructions and we're out of it. So what we did is we set up the object, we set up the camera, and now we're just going to finish off the thing by making it work. I'll show you how it works here. It's 2 instructions. It looks like a lot, but actually after you get used to them, they're all the same. They're always there all the time. They don't change anything. This one's called renderer. Dot set size, and that right there is capital, size is capitalized, and then I'm going to call it frame width. I'll explain these in a second. Comma, frame height. Now here's what that does. Frame width, that's frame, F-R-A-M-E, frame width and frame height. That's actually the size of your normal screen, whatever your screen is. If your screen is, 1280 by whatever it is, that will be how big frame width will be, frame height. They come in built in, it's built in. Supposing you don't want your image to be the entire screen, you only want it to be half the screen. All you do is divide by 2 right here, you got it. It's going to give you half the screen. In other words, the frame width is the whole screen. Whatever you want to do, however you want to break it down, it's your business.
You also
break it down.
divide like 4, 8, 12.
Yeah, you can do anything, any number you want. It doesn't make a difference. It'll divide it any way you want. So basically, you make a fraction out of it, and it'll present that part of the screen. You got to be careful of that though, because don't forget, you've got proportion problems here. Don't put a third and a fourth over there, because that'll distort the thing. Oh, you could if you want to, but that's what you get. So that right there is the first thing you have to do, is just to simply say, okay, put it on my screen and put it on the entire screen to start off with. And now the actual function that causes everything to happen, this is it here. It's called renderer. Dot render. Scene. Camera. There it is. Finish. Into rendering function. So we set up where the objects were located, rotated, where the camera was located, and now we're simply saying draw the picture. How big the screen is going to be, and this right here is going to say draw the scene, put the camera where it's supposed to be. Boom, you're there. Okay? It seems like a lot, as I say. But once you look at the program, you'll see over and over again, it's the same old structure we've been using right along. You've got the head, which contains all this rendering stuff. Then you have the body, which contains the graphics XX, which says this is what we're going to use. The body has very little in it. It basically, all it has is, these are the objects I like to put in my scene. That's what all comes in the body. And then you use the render, inside the render is where you actually orient all the objects, you tell it where to go, what to do, and everything. Okay? And that pretty much is how it works. This is the most basic program. It's online. And take a look at it, and all in one piece, so you can see all how it works. And I also added some of my notes up to it, notes on how these things work. If they raise any questions that you can't figure out, it doesn't make any sense. Don't forget, this is going to be this lecture and the next one too. I'll get you into the graphics much deeper. But and I'm going to tell you something else in advance. You start off having to think about all these things, about how to do this and how to do that and how to do everything. But what I do is I've written a program that actually even takes all that away from you. It actually allows you to put walls up around the room and put objects in the room and then it just comes up with the ceiling and all that, so it builds it all for you, okay? The whole idea, I had originally, I was just doing 3D graphics, but I had a couple students, one was an art student, one was an advertising kind of guy, and we realized that what we really don't have online is when the thing comes up, you're in a 3D room, and you can look around and do stuff in the room. Press buttons, make things happen, and you have images and objects, whatever you want. In other words, you're built in this room, and it's built in such a way that you can't get out of it. In other words, you're in this world, and you're in it. So in other words, it's not like they can press a button and the whole thing blows away. You can stop the program, but you can't get out of it. So the object was just to make a room that was this imaginary world that you want to create as an advertiser or as whatever you're doing. And the people who are coming to see it can move around in it and look up and down, do all kinds of stuff, but they really can't walk through the walls. Well, they can if you let them, but you can set it up so they can't walk through your walls. So they're there, they're in the world. And that makes it more realistic for people to experience than, you know, if WoW, for example, early on in WoW, you could walk into a wall and your object would get caught in the wall, and they had programming problems there for a little bit of time. That doesn't happen anymore, hopefully. But essentially, you don't want to destroy the illusion by letting people out of your world. So that's what you do. You get into the world, and you can jump to different worlds. While you're in this world, you can go to another imaginary 3D world or another one. We can do that. You can move all around. But they never have to exit your world as long as they're in your website if you want to do that, okay? So that's the reason, that's where it all ends up. But I'd like to get in there by showing you the details of how it started off, okay? I have an example I'm going to put up this week. The first one we did actually was it was an Egyptian tomb. You're in the Egyptian tomb, and it's kind of weird, and you're in there and you can't get out. You know, it's not like a game or anything. But you're kind of in there, and the walls are like, you know, Egyptian walls, and you're kind of can't get out of that thing. But that's it. That's all I want to do. I'm going to do go to the computer now. If you any questions? Anybody have questions about anything at all? This will be where we're kind of headed in the next rest of the course. I might backtrack occasionally. I might come out of 3D just for a short session of giving you some extra tool that I want to amplify a little bit, okay, or review a tool or something. But other than that, this is pretty much what it will be.